Welcome to MTD Podcast. I'm joined today by Matt Kavanagh, Head of Engineering at MSC Industrial Supply. Welcome aboard.
How you doing, Colin?
We're very well, thank you very much. You're going to tell us all about a great new service from MSC, but before we go into that, we're also joined by Paul Jones, MD, and tried and experienced engineer. Is that right, Paul?
Yeah, 100%. 100%. Used the tools, used the machines.
Yeah. Well,
made some good bits and made some bad bits.
Yeah, more bad bits than good, I heard. But you did actually do your apprenticeship at Allen's as part of the Rolls-Royce Group many years ago.
Part of the Rolls-Royce Group, yeah.
And the reason I
didn't get given one.
Okay, no, fair enough. But the reason I wanted to introduce and identify and go through what Paul has done is because we've got a great new service product, which is the MillMax, which is what you're going to tell us about today, Matt. I've done a lot of research. I don't profess to be an expert. That's why we've got you here. But I wanted to get Paul involved as well because he is, in all seriousness, a tried and trusted engineer, but he's an engineer by trade.
He's awash with compliments.
A lot of experience. So
questions are on his script.
Questions that I might not think of, he'll throw out, and we will put you on the spot. Absolutely.
For sure, yeah. So, do your best or worst.
Straight away, MillMax. Tell me more about it. It's a brand new, I'd say, product service from MSC. What is it?
Yeah, I suppose in a short and sweet way, it's an exclusive product to MSC.
Yep.
It's a piece of software and hardware that is a product service to our customers, and it defines where stabilities are in the machine within just 15 minutes.
So in very simple terms, from what I understand, I can massively increase my removal rates, reduce cycle times, improve surface finish, little things like, well, not little things, some of the things.
Yeah, for sure. I mean, they're quite monumental in the industry. I mean, chatter, vibrations, resonance, whatever you want to call it. I suppose just for some continuity, we'll call it chatter for today.
Yeah.
But it's been around for generations. What we've done with this MillMax is actually refined through scientific approach. A gentleman called Tony Schmidt, who actually wrote the book on vibration. He developed the software through Oak Ridge National Laboratory in the US.
And this gentleman is a professor, isn't he? I understand.
Yeah, for sure. Yeah, he's very, very elite within the industry. He's been working on these scientific practices for a number of years. As I say, wrote the book on vibrations, and he's been able to work and find the scientific approach with the multiple algorithms of the problems that you've got in the machining characteristics, and actually quantify it within some software to give some really simple information out that some technical engineers
I'd say it's not simple information, but all this information you're combining with the algorithms, with the software, is making it very easy for engineers to understand and optimize their machining processes, be it increased metal removal rates, reduced cycle times, etc.
Yeah, for sure. I mean, trying to get the optimum metal removal and trying to get the efficiency out of your capital equipment is a minefield. You can sometimes, what do we do with the engineers? We have a look at a book data. We have a minimum, maximum surface speed, and we tend to go for the middle because then we can either reduce it or we can increase the surface speed and try and optimize it. When we get to that middle range and we hear chatter, our first instance is to probably reduce the spindle speed down to slow the resonance or the chatter to try and stabilise the environment. Little do people know that there is actually other stabilities within the framework of that machine or the characteristics of that machine. What engineers do in the marketplace is they can sometimes stumble across that. Sometimes it's luck, sometimes it's knowledge and expertise. But what they also do is they refine and then finite adjustments over days, weeks, months.
So just leaning on the machine as well, just to feel
listening. But what we're saying is we can literally, with an instrument, tap the tool and understand what the best qualities are and the most stability within 15 minutes.
The MSC factor is quite a big part of this too as well. I'd probably like to get that out in the early days, because one of the questions I asked you before this podcast, Matt, is it all just about the product, or is it about the company that are supplying this service, which is what MSC are very proud of and very good of? Maybe you could give our listeners that don't know a quick overview of how your skill sets add value to the product too.
Yeah, for sure. So I suppose the fundamental thing is MSc engineers aren't engineering team that just basically regurgitate data out of a book. We have a look at the nuances of the machine, what the stability is, what the machine's capabilities are. And what we do is we put the best practice around there. Now, MillMax gives us a really good advantage over the marketplace that we can actually pinpoint very quickly of where them optimum stabilities are. Now, not just is it great to get the stabilities of a certain machine and setup and assembly, what we can actually do is drive the characteristics to actually define the right strategy for metal removal as well.
Yeah, because when you sorry, Colin, but you got two scenarios here. I mean, we've got engineers that would consider themselves quite knowledgeable. So when they purchase a machine, they look at things like the build of the machine, how solid it is, how stable it is. When they select their tooling, they consider whether they need balanced tooling, whether they purchase their cut. You know, there's all of these factors that come into play here, isn't there? So does it matter is there always something to gain? I suppose this is my question to you, regardless of how good you think you've got things in place with your infrastructure. Can you still make positive gains?
Yeah, I suppose that's the key thing about continuous improvement. It's all them finite changes that makes you better than your competition. MSC want to engage in that because of, yes, we've got MillMax, but the capabilities and skill sets that we've got as an engineering team. I think I did some added up all the ages and took away the kind of when they started the industry, and we've got about 500 years worth of engineering experience in the team. I mean, it's phenomenal.
So if I ever said to you, okay, well, I've got this brilliant machine, I've got this brilliant strategy, this brilliant solution, you'd never come and use your piece of hardware and software and go, actually, I can't do this any better. Is there always something that this product can help you with?
I'm going to cut in there because sorry, Matt, and sorry, Paul, because each individual machine, like everything pretty much on this planet, has its own individual resonance. So when you're putting a machine, spindle, tool holder,
well, you don't vibrate.
Whatever, Paul. But they're all unique, and that's what this is identifying. You're giving it the tap test. You're getting that unique profile for that setup, and that's what you're looking at.
Yeah,
and then this software will then optimize all that.
Yeah, so if you look at a machine as like a thumbprint, so everyone's human thumbprint is unique.
That's a much better analogy, thank you.
So whether it's the concrete that it's sitting on or vibration pads, whether it's the linear rails on the machine, whether it's the inline spindle or belt-driven spindle, what we're trying to detect is the vibrations come from the machine assembly, and over years and age in machine, you're obviously going to get more vibrations because of wear and tear.
Yep.
What we're trying to do is not just look at what the tool's doing, but the actual capital equipment for the customer, because fundamentally that's the bread and butter of a business's company. That they've got to try and maximise the revenue out of their machine. So coming back to your question, Paul, about, yes, it's great to get all the fundamentals in place, whether it's the hydraulic, power chucks, the right tools, the right machine for power for load and power removal, or lightweight machines for, I don't know, other applications. That's all great, but there are still finite adjustments, because engineering is such a grey area, and that's the fun part about engineering.
You go to one machine shop, and you'll have 3 different engineers making that same product in 3 different ways.
Gosh.
And that's what you're trying. Is that part of what you're trying to do? Is stamp that out?
I remember some years ago we had a competition. I was working for in an application role, and we had a case where there was different countries doing exactly the same job, doing exactly the same thing, but who can beat each other? Different applications. It was just crazy. It was great though, yeah.
Yeah.
So what happens is in the industry is, sometimes you can get in businesses, let's say 2 or 3 different programmers, and then programmers can like their strategies or like the particular tool or their own nuances about how they like to attack a piece of material or whatever that may be. But what happens is it has a knock-on effect within a business for what I see and what MSC try to help our customers, in as much as that if you've got 3 different variances going on the shop floor and 3 different lots of data, I'm coming back to MillMax now, so what's that stability? it has effect on the shop floor because you're not getting the consistency. The operators, the setters, they're not having the right data. The same piece of material, okay, the net shape of what you're actually manufacturing might be different, but the data really shouldn't change because of that stability and the certainty in the production environment.
Okay, so you're basically trying to give stability within that machine shop. Everything, the process is there, it's set, and you're making yourself, ultimately you make yourselves more efficient.
Yeah. So if you've got a unified best practice, it doesn't really matter if you've got raw data that doesn't really, it can be achieved, you get more out of it, it can be achieved better, but that's okay. That's a level platform. Work from that.
Okay.
But when you're spitting out this, and I know we're going to talk in there, I'm going to ask you in a minute to walk us through how it actually all works. But when you're making your assessment or you're doing your test, your tap test, does it matter what the products that are involved in this, let's call this thumbprint that you talk about? Because these thumbprints have different control systems, they have different, there's a myriad of options. You go into one machine shop and you'll see a machine with using a FANUC system that's programmed using, Hypermill software. You'll go somewhere else and it's a control from, day dot. Where can it start and where does it end, or can it work with anything?
So fundamentally, whether it's different CAD systems or different machines, I mean that they're always going to be there. What we're talking about is a finite setup of a tool assembly. So for the purpose of the cameras, I know it's a podcast today, but we've got a tool here. So each machine is looking for the right character, or the software, shall I say, is looking for the characteristics. So it's looking for the actual back end of what the tool is, BT40, BT50, HSK, plethora of what's on the market. It's looking at the actual overall length of the tool holder. It then looks at the ejection distance of the tool. It looks at the load, so the kilowatts of the actual spindle. It looks at the actual maximum spindle speed of the machine.
Yep.
And then it takes into effect all the radial depths of cut, the length of cut and so forth. And we can actually determine where the stabilities are with them characteristics, even as much as the accuracy and the surface finish as well.
Right, so at the beginning of this tap, so what you do is you'll have it in the machine, you'll attach a sensor to the tool.
Yeah, so again, so we've got... essentially, it's a hammer. We like to call it an accelerometer because it sounds a little bit nicer.
You can't call that a hammer. We'll get in all sorts of trouble calling it. So it's an accelerometer. Okay,
a refined hammer, yeah.
Absolutely. So attached, and then you've got a sensor on the other side of the tool.
So we've got, so coming from there, so we've got a hammer with a cable that comes from there. Yep. On the actual tool, we have a vibration sensor that, again, it's got a cable that comes back to some hardware.
Yep.
The hardware then, or the software translates when you strike a tool.
Yep.
It translates what the resonance is from that tool back into the software. Now, the actual software knows if you tap the tool too hard, it comes up with an acknowledgement that I've tapped it too hard. If you've tapped it too soft, tap again. It also denotes whether you've done a double tap. So it really detects and wants to know the kind of frequencies that looks right.
So all this software is working in the background to keep it relatively simple for you guys.
For sure,
to get some great results out at the end of it, though.
Where's the data spat out? Where does the data go? So into an iPad, onto your phone, onto
It's a bit of software on a laptop, and on there you can actually see the coherence of the resonance. So you can see, even if you've done a tap and the software allows you to do it, this is part of the kind of the technical know-how of the software, that we actually look at the coherence of what we're getting back from the software.
Sorry, what do you mean by coherence of it?
So the actual frequency. So
Right.
so the best way I can explain, like peaks and troughs on an oscilloscope. So if you was looking at your heart monitor at the hospital, when you can see them peaks and troughs,
Yep.
what we want to try and do is stabilize that as much as possible, and that means that the tool effectively isn't wobbling resonance.
So there's an element of compensation. If it looks like this, for example,
That waveform,
what
yeah.
you want to try and get is this.
Yeah, for
Sorry,
sure.
just
Just
that's
taking
what
this-
the software does.
Yeah.
Right. It smooths that.
That peaks and troughs
Peaks
out
and troughs.
within a given RPM, so how fast the speed's going. If you end up going into a different quadrant, you might see them peaks and troughs come. So you want to try and get in between the certain peaks and troughs.
Can I just stop you there, though? So take a step back. You've tapped it with your accelerometer. not a hammer, just to clarify. That will actually show that the resonance on a separate chart, which you can see. I mean, again, this is a podcast, so it's, but then that'll take that information and it'll actually put it into a dashboard so the engineer can see it. So you put in your data, you put in your RPM, your spindle speed, your HP, what machine it is, and then it'll actually come up with a dashboard for the engineer to see, and then they can then...
For sure. So it works on like a bit of a traffic light system. So
Right.
green, stable, amber, unstable, red, chatter, stay away. But the actual small intricacies of where that stability is, it's so accurate.
Right.
What we've actually done tests this software has been already launched in the US, and the US have got certain values that they've said, okay, we're doing a 170% metal removal.
Easy for you to say.
I'll spat that on out. 170% MRR efficiencies.
Wow.
So obviously they've launched it for quite some time. It's new to the UK. We've done some tests, and I can positively say that we've matched what they've said. So,
but again, just looking at, so you've done your tap test, you've got the resonance of the machine. Let's look at the whole machine, the spindle. Each one is individual. You then got that dashboard. You put in your data, and you can see. I mean, I'm just trying to give a picture.
Kind of like a speedometer.
Speedo, yeah. So Paul's always in the red. I like to be sort of in the green. But what we're alluding to here with this dashboard, you might have a 12,000 RPM machine, and engineers will go up to maybe 6,000, and you start getting that chatter, and then they'll back off.
Yeah, I suppose
which is what normally happens
in a real life world, and I've been on the shop floor myself. What you'll see is you pick a surface speed, you pick a feed, you start engaging the tool into the material, and if you hear chatter, your mates are looking at you. You're thinking, what are you doing? And you're running down the spindle speed to try and get some stability. You might, if you're feeling brave, pick up the surface speed, or you might to try and get stability, or you might pick up the feed, depending on your kind of knowledge. And I suppose that's where MSC can also help with our engineers.
That's a bit like driving down a bumpy road, isn't it? Sometimes if you go faster, you feel less of the bumps. It's true though. It's a similar sort of thing. If you go slower, you feel more of the bump. So it's trying to find what that sweet spot is, isn't it? That's what but you can only do that by hear and by feel. But now we're able to look at it actually in its real form.
Yeah.
And again, having seen I think you've seen the dashboard as well, but it's brilliant because, I just said the figures, you got 6,000, but then you can change the axial and radial.
Yeah, so I mean, this is the great part. People look at this software, and the way that sometimes it can be interpreted is that when you,
as if by magic. I know again, it's a podcast, but you could see it behind me.
Perfect. Here. It's a shame we can't change where the crosshair is, but. Okay, by magic as well. There we go.
Working magic again.
So you can see on the crosshairs, when we start moving it around, you can see where the red and the green actually start moving. So actually, if you've got chatter on a tool, you just tap the tool and it'll tell you where the stability is. Now, to be quite honest, our engineers would be looking at, okay, what's the tool holder, what's the, additional adapters, and they try and get the actual application perfected and then tap again to get the optimized results. But what you can also do is, if you've got a new setup and a new tool, and whether you think it's rigid or not, but you've got that setup and you want to understand what strategy you're going to start utilizing, whether that be high feed or whether that be full slot or whether that be trochoidal, you can actually look at the metal removal against the cycle time and use these crosshairs with different tools to actually see, okay, what's going to be my best practice? What am I going to do for my cycle time and get the metal removal out, because I've got production demands, I've got X amount of things that are waiting, and I need to get these products out as stable and as efficient as possible.
Okay.
So I'm not doing this on I'm trying to establish now how much labour is involved in what we do here. I'm not doing this in every machining operation or every tool, am I? I'm not slowing down my overall production time and my cycle times because I'm spending an inordinate amount of time tapping my tools. It doesn't work like that, does it?
No. So obviously when you speak to a technical representative from MSC, we'll be taking a load of characteristics from you before we even get on site. whether that is a picture of the actual tool, what's the tool holder, what's the ejection distance. So we'll start populating all the data before we come on site. We'll ask you to have, if it's a roughing operation or a finishing operation, just please press feed hold at that point. And then when we're ready to come down and execute, we'll tap the tool and then we can press NC start to make sure that we can actually look at the results as well.
This is a great solution to improve metal removal rate, I could say that, but you can not trade off, is that the right word? You could say, right, I want higher metal removal rate, or I want longer tool life, or I want better surface finish.
Yeah, definitely. So yeah, you can actually depict whether you're going to use it for an increased surface finish that probably won't get you the actual accuracy, especially when you're looking at finishing and roughing applications. And then also for accuracy and surface finish specifications, you can actually get the software to detect which one will be the most stable environment for you, especially when you're doing kind of thin wall finishing or really long pockets as well, when you've got extremities on the tools.
So I'm thinking that's going to take that, if you're going for the surface finish, for example, that's going to save you more time and cost, because it's going to take out other operations such as your deburring or your polishing and grinding and things like that, potentially?
I think that for me, them are all part and parcels of what we try and do to mitigate extra operations. But for the actual purpose and the operation itself, is the tool going to leave the right surface finish for us? Are we going to have the stability? And for me, this software is absolutely phenomenal and great, but for me, the conversation to a business is get stability and certainty, and the optimum performance. And that's what this software
how quickly and how long does all this take? Because I mentioned earlier about, do I have to do this on every tool? Do I have to do it every day? Do I do it once a month? Do I just do it at the start of a quarter or the start of a project? Just tell us how that works, because that's a big part in what's involved for the actual end user themselves.
Yeah, I realised we didn't get to that answer, so apologies for that.
That's why I asked you again.
That's all right.
If we end up tapping every tool, we'd be there for ever and a day. Yeah, I mean the amount of businesses that have got thousands and thousands of different tool setups, and what we're there to do is to utilise this software when we're looking for, particular cost savings in customers, or particular parts where they've got high scrap usage because the surface finish implications aren't the best. It's about how do we guarantee that customer the right precise outcome, and we would just be looking at the specific tools.
Got it. So you got a part. You come into my machine shop, one of your very technical and skilled engineers comes in and goes, we could maybe make that a bit better. Let's see why you're getting such tool wear. Let's see if we can get it through the shop quicker. Let's see if we can make these. And then you would perform your test. You would then get your result, and then you would implement the better strategy, the better ways of doing it in order to improve these things. And then that part would then run for its life. Yeah. And then you could come in to do another part or another machine. Is that an example of how it could work?
Yeah, for sure, 100%. I suppose MSC are a supplier of metalworking, MRO, PPE. We have vending machines and we look for consolidation. But the consolidation part and offering a tool is just a service to the supply chain. It's all the additional services and products that we've got through hardware and softwares that really help support that, and we help them specific operations to get the cost savings, to get them better than their competition. So
I think key to that as well is the fact that it's not just about providing tools, tool holders, the tap test, the MillMax. You've got, and I think the numbers keep changing because it's going up all the time, about 20 time-served engineers with hundreds of years of experience. So you're going to turn up and you're going to really add that value.
Yeah, 100%. I mean, sometimes you'll speak to technical expertise, and we've got to go and speak to someone in Germany or someone to get the real niche information. The great thing is that our engineers are time served, so whether you've got a stable tool in one instance, in one machine, and then you think, great, I'm going to go and use that on a different machine. Sometimes it doesn't quite work right, but we've got engineers that will look at all the factors on the machine and go, okay, right, I need to do this, I need to change this. This is the reason. It might be backlash on the machine or something. So we'll have a look at all of the instances and use our technical capabilities.
So who does this fit then, Matt, as a business? Who's your ideal candidate? I mean, obviously it's a very new product, and you've said you've had some great results coming out of the States. Who do you identify that can really get some good wins out of this?
I think everybody in engineering, to be quite honest, but the fundamental part is, obviously it's exclusive to MSC. We want to have leverage in the marketplace and be able to support a plethora of customers and suppliers to the manufacturing industry.
So we don't just come along and we buy one of those, you send us an invoice, and it comes as a part of a complete engineering solution from your team.
I think that's a key word, isn't it? It's a whole solution you're going to be providing.
Yeah, 100%.
Absolutely. Okay. I've got a couple of questions for man. I'm going to put you on the spot here.
Shoot.
So, is it, any machine, any type of tooling, any type of tool holder?
So I suppose it's in the title MillMax. So it's
all right.
Sorry. So it's a milling machine. So it can't be used on a lathe. But if you've got, there's been some questions, can it be used on live tooling on a lathe? Well, if the material's fixed and the tool's rotating, then yeah, for sure.
Okay.
Can it be used on single point boring bars on milling machines? Well, yeah, it's a rotating tool.
Are you reading all my questions I've got written here, mate?
Sorry.
So you're hitting the tool when it's stationary, when it's spinning, just to give us a real flavour of...
Yeah, I suppose that's a really good point. So yeah, we'll tap the tool while it's in a static position. Yeah.
Okay.
And in the machine.
What about the work holding? Does that affect it? You're holding that billet and...
Yeah, so work holding is another factor to take into consideration. And again, that's something from what we support from an engineering team at MSC is about the stability in the workpiece. But I suppose it works exactly the same if you've got a really stable tool and a thin wall, inflexible workpiece, you're going to get resonance. What we're saying is from the actual software itself, we can actually have stability in the tool, the workpiece we work with.
This will give you some great data and an ability to really influence companies as to what they should and maybe shouldn't purchase, won't it? Because you'll go out to sites, you will, do your tap test, and there'll be some machine tools and there'll be some complete packages that you'll go, this is pretty stiff, or whatever the word would be, and there'll be others that you'll look at and you'll go, actually we've tap tested this kind of machine on many occasions and we've seen a lot of resonance here. So that can give you quite a good steer as to how to help your companies, not just maybe with their solutions on the tooling, but everything that goes around it, can't it?
Yeah, for sure. I mean, MillMax will be a large part of that. But I suppose the fundamental thing is MSC.
But you'll see the results. You'll continually see what works well and what doesn't.
100%. But it's without that brand bias. We're always checking to make sure that it's the right application and the right tool for the job. MillMax will help us quantify that. And then there's leverage then on how we help the industry with that data that we've got. Because everybody should, I'm not saying everybody will be able to use the same data because of the machine characteristics, but if they've got similar machines, then yeah, for sure, come and speak to MSC and we'll tell you what we've used in previous occasions.
And then you'll come out and do the test, obviously.
Yeah.
What about different materials? You're talking your Inconels, your aluminiums, your plastics.
Yeah, so
composites.
All of this is taken into consideration. So you can actually define your own materials if you go on to some advanced courses with the software, but there is your P1s, P2s, Inconels, titaniums. Actually,
I'm just looking behind, I've got on the screen behind, I know again, reiterate, it's a podcast, but on here you can actually put in different material groups.
Yeah, and you can put different characteristics of the materials in, but that again is from the technical resource from an MSc engineer.
Okay. As a business, you must be forecasting and thinking, right now we've got this here. Where do you want to see it in a couple of years' time, or how do you perceive it will be received, and how many people will you be tap testing?
Well, I hope it's received well. It is a differentiator in the marketplace, and it's amazing that we've got that differentiator at MSC. I'd like to think that just as well as having MillMax, but with all the other additional services that MSC offer, and again, it's not just about that bending with providing the tool or that PP or MRO.
You could end up selling less tools though if they last longer. You could end up, there's all these things, isn't it? It's like sometimes we go to machine tool companies and they you know, they're now selling an automation solution to load a machine. And you go, well, you know what? If you sell that automation system, you're probably not going to sell another spindle because they might not need it. But, you know, you're doing the best for your customer.
Yeah, I mean, we recently went to a customer where they were just about to purchase another machine, and we'd done a business needs analysis, and we said, why are you purchasing another machine when you've got a third still left of efficiencies in that machine? And we've actually proven it. We've gone in there and changed the actual application, and they haven't bought a machine now. I mean, that's what, 250,000 pounds worth of
course, so some poor old salesman's lost out on a machine order.
but we're here to support the marketplace,
course,
and a sale is a sale. Let's just park that for a minute. It's about how you support the customer.
Yeah.
It's about the British industry. And I know probably people see MSC on there, but take that away. Our engineering team and our business, and for sure me, so passionate and making sure that we're doing the right thing. I got asked the question the other day, what's your best saying that you would say to someone? And it was, do unto others as you would do to yourself.
Yeah.
If I wouldn't expect the expertise and the knowledge in the field, our customers should expect the same.
Absolutely.
So I'll be interested to see the case studies on this in months, maybe down the line, because this will be where, you know, you can talk percentages, but in real life situations, we need to be able to get to grips with that and go, do you know what, this is really is phenomenal.
Yeah.
Really.
And that's what I think will be interesting to see in months to come.
If I just come back to your other question, Paul, sorry, where you said about we'll actually be losing sales, because we'll be doing cost savings. Our engineers, their KPIs are to deliver contracted cost savings for our customers. So we stand by what we do, but with customers that we've and what we've experienced to date is that the more cost savings we do, the more efficient the company is, the more time that they've got to actually pull more businesses. And we've actually seen our business and our customers grow and invest in more MPI work. They've been able to actually, I mean, to be able to do CI work when you've got a load of MPI work coming in, it's just phenomenal. So you're not running around. And again, it comes to that stability, the efficiencies.
Yeah, which all ties in with the MillMax. Can I just sort of funneling down a couple more questions on the actual MillMax itself? The tools, any type of tool?
Yeah, so we indexable, variable pitch helix, standard carbide, HSS, cobalt.
So any tool. What about through coolant?
Through coolant,
Not a problem.
Yeah.
Okay. Any size, so diameter, length.
So of course, obviously, with the instrument, and you're actually tapping the tool, the accelerometer. I would probably not go down any more than 8 mil, only because of obviously the inflexibilities of the carbide. You don't want to be breaking any tools. And then we've also got there's actual again, I know we're on a podcast, but there's actual a thread on the back, and you can put a weight on there. The software tells you when to put the weight on there. So if you've got a certain diameter, if it's for an inserted tool, it will say, please put the weight on there, and we will do up to about 150 mil diameter. You could put more weight on there, but I mean, how far do you go?
Is there anybody that's listening or watching this that will go, oh, well, we've already got something like that? We always do. We already assess this. You know, are there many? Because this is new to me, and we do a lot of travelling at MTD, going around companies and seeing new products being used. But will there be anybody that will be thinking that?
As I say, I think we said at the start, the chatter, vibration, resonance, what you want to call it, it's been around for centuries. And to overcome it has been a nightmare and a frustration for most in the industry. There are things that people will look at tapping fixtures, and they'll have a vibration sensor on there to see if it's stable, and they'll put pack in, they'll change the fixturing to try and make sure that it's a dull noise without any vibration.
Very manual ways of doing it.
And it's very manual calculation. There are things that you've got vibration sensors on machines, so it's looking at the bearings, but it's only looking at the actual bearing rather than actually what's going into the... But for me, this product is
because wouldn't a machine tool supplier be developing or have something developed in their control system, in their, you know, a lot of these controls are moving towards the Industry 4 element. They've got maintenance within them, they've got diagnostics within them. Is this not something, is there anything similar, or is there any way that a machine tool supplier could have something like this in their own solution that would identify and give similar data to what doing the tap test does?
So I don't. No,
no, but each pushing back on that though, you might have your machine tool, but each sort of configuration is different, because you've got the spindle, you've got the machine, you've got the spindle, you've got the holder, you've got the tool, and by the time you put them all together, there's so many different variables. So
well, yeah, I mean
that's taking that out, I think.
Just to add on to that, and I know that no kind of, I didn't want that to be like a full stop at the end. There are machines that have got vibration sensors in there, and they will look at the spindle to make sure that the bearings, whether that be for warranty purposes or whether that just be to support the customer's manufacturing purposes, that's what they're there for. But then you add on more assemblies to that spindle. So it's kind of like when you if you was trying to lift something really, really small, then it's great. The longer it goes, the harder it is, and you get more resonance. The more
it's like if you
the extremities that you get.
A car being driven with just one person in it, the manufacturer will roughly know how that's going to handle. But if you start sticking suitcases on the top, something in the boot, something out, you know,
it's not monitoring that assembly. No.
People who don't know MSC, you've got a fantastic engineering team, you know, and it's not just about selling tools and things like that. Tell me more about them, but let me reiterate, I don't want every individual name.
Yeah, there's 20 of them, so yeah, I won't give them all away. So yeah, we're apprentice trained engineers. We're not just looking at a catalogue and regurgitating data out of there, because hey, anyone can do that. It's just a matter of remembering the data. What we've got is an engineering team that actually have a look at the application itself on the actual machine equipment. So the setups, the fixturing, the inertia of the machine, the load of the machine, and we use all of them, that quantified known data, in able to either optimize or set a job up, much like what a machine OEM would do, a machine tool sale OEM would do, because they want to make sure that that machine is shown off in the best light and the best way. And they'll use the CAD/CAM systems to make sure the strategies are right, to make sure that the tool contact is fine, so there's no air movement. So the engineers are looking at all of the different intricacies, the different tools that are in the marketplace. And once you bring all of them elements in and use MillMax on top to make sure that you've got that optimum setup, you can really start integrating how you use the CAD/CAM systems. And what we do as an engineering team is we utilize all of that experience and knowledge from the physical world, but in a digital transition. What we do with the customers is actually set the fixtures up, put the work pieces in there, show them the actual tack times of actually the tools on there. So it's no longer like wet your finger and put it in the air about what's that time. It's actually physically what's going on with the CAN systems. I know there's like a 5 or 10% plus or minus figure on the actual output of the cycle time, but the engineers give a proven test about collision avoidance on there of that tool assembly against the component model. They're looking at bespoke fixturing and putting that on there, and also looking at automation. So it's a complete service that you probably will get from an OEM selling a machine tool. But our customers, because this was a really long answer for your question, so apologies, but
it's a good listen.
But our customers, or businesses or MDs, when they actually buy a machine, they're spending like, I don't know, 100, 150,000, 200, £500,000. Yeah, it's a huge investment in their business. And sometimes the supply chain can not be looked in the right way, because it's very much in the moment. This is a tool, it costs X amount. And actually the supply chain, when you look at it in a complete entity, it's the cost of a machine. So the MD or whoever, the procurement people, when they're really looking at that CapEx cost for that business, everybody was so wedded to make sure it does what it does. But just as a supply chain, they should look at that exactly the same. And our engineers make sure that whatever we're supporting into their business from a consumable product, we have to make sure that their capital equipment is working to the optimum performance.
The environment we're in at the moment, we all know what's going on. It's given sort of engineers, the MDs, machine shops time to take a step back and actually reassess how they're working. So how does what MSC and MillMax tie in with that?
Yeah, I mean, for sure, when you look at things, and it's on everyone's front of mind, COVID, it's given companies a lot more time to have a look at how they're machining things, what's the best practices within their businesses. And what we're looking at the moment is the industry. I mean, everyone can see it's on a trajectory that we've never seen before. I think there's some figures going out, but I heard some 1941. We've never seen such an elevated.
The year Colin was.
Don't do that. I knew that was. Why'd you do that every time, Paul? But anyway, that's not.
I've been waiting for someone to say that, to state that fact for ages, so I could drop that.
Sorry, carry on. Silver is a new blonde, by the way. But
moving back
to
so.
So they're reassessing how they're working.
Yeah, so they're reassessing how they're working, especially when you think of like the things. I mean, it's on topical point of everyone's conversations, like reshoring. So when you start getting businesses trying to take that work back in house, now they'll also be looking for NPI work, so new product introduction. When they've got this new work in, when they've got that reshoring work that they may subcontract out previously. How are they making sure that that's efficient, optimized, that stability again? We've got to help support that throughput for customers, and MSC engineers really take effect of how we can make that streamlined.
It's an interesting point because you talk about people looking for new business, potentially changing their business in current circumstances. But where is your angle and your aim for this particular product that we talk about here? I mean, are we talking about small companies? Are we talking about production facilities, tool rooms? Where exactly does it fit, Matt?
Yeah, it's a great question, Paul. So if you think of a production shop, most people will probably tend to think, okay, this tap test is great. I'm using same material, same machine, running all the while, tap test it, and jobs are good. Actually, what you can do, it's that quantified data. So if we just think about parking the actual tool assembly and all the actual granular detail and just think about the actual data. Yes, that's great because now we know what we're going to be utilising. But if you start looking at that tool assembly when you've got small production, so like a dynamic workshop where they've got 2 offs, 5 offs, 10 offs, whatever they are, and let's say they're all machining in, I don't know, aluminium, stainless 316, titanium, whatever it may be. If they've got a tool that's set up in a certain assembly, so again, I know it's a podcast, but we've got a tool ejection distance and a tool setup, and that is the requirements that will always be on that machine. If you're looking at a roughing application, let's say, and you know that quantified data is X amount radial engagement, X amount of depth, my speed and my feed will give me a really stable engagement through the shop floor. I know how long that tool's going to last. I know when the operator needs to change it. So now we're starting to create stability. So now really it doesn't matter if it's always in 316 stainless, let's say, the actual prismatic shape of the components can be anything, but the actual way that you remove it will always be the same. So it really doesn't, for me, it doesn't really matter about whether it's a long production or a small dynamic workshop. It's about utilising the tool with them, the kind of like rules of engagement, and using it with that data.
So it's not a man with one machine in a garage. Oh, sorry, it can be a man with one machine in a garage, and it can be a company that's got 200 machine tools. The answer to the question, really, I suppose, is everybody.
Is everybody, yes.
Yeah. Where are you going to be in 2 years' time with this, though, Matt? With this let's say, brand new revolution, this new way of monitoring these things. What's your projections as a company?
The expectation is we're supporting the complete UK manufacturing industry. I would love to be in a position where people see MSC Built to Make You Better as a brand, and they know that they're going to get certainty, efficiency, a level of technical capabilities. And not only that, we've got hardware and software solutions and services that really bring out the best qualities in their production environment.
So there you have it. Matt from MSC has given us a fantastic summary there in every machine shop ultimately. So thank you for joining us. Paul from MTD, my MD. Tried and tested engineer, debatable, and Matt from MSC Industrial Flight. Absolutely fantastic. Look forward to getting out there and seeing that MillMax working. Thank you very much.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.